Today is April 5th, 2011, and I'm going to practice the think aloud strategy. First, I'm going to read out loud, and then I'm going to do the think aloud. We'll do it on separate videos. Ready, set, go. Lab, friction investigation. Remember, this is not your lab. This is another lab that you're not doing. I'm modeling it for you. When you kick a soccer ball along the ground, you know that when you stop kicking the ball, it will eventually roll to a stop. What happens to the kinetic energy of the ball as it slows down? The law of conservation of energy states that energy cannot be created or destroyed. Therefore, the kinetic energy of the soccer ball does not just disappear, it changes form. Where does all of that energy go? This is a laboratory investigation and an eFolio project. Get out your cameras, smile. Essential question. How does energy transform when an object slides or rolls? Or, why does something stop on its own? Investigative question. How does the rolling surface affect the energy transformation of a rolling car? How does the rolling surface affect the energy transformation of a rolling car? Procedure starter. At a chosen height, determine the gravitational potential energy of a matchbox car. Think of a way to show how the energy transforms, possibly using different surfaces to make it obvious. Share the results with others on your eFolio. Connect with the essential question. There's a hypothesis with a blank, there's variables with a blank, there's a control with a blank, and a procedure, and a suggestion. I suggest making a ramp. Don't forget that you know how to calculate the downward force of a car. Here's a hint. Think weight. Also, you know how to calculate work. See if you and your group can put these concepts together to figure out the GPE of the car at the top of the ramp. When you know how much energy the car started with, you might be able to devise a way to know how much energy your car lost by the time it stops. In your eFolio, you can talk about where the energy goes. Here's a table. It says object type, surface, ramp height, initial GPE in joules, and what other data might be important. So there's suggestion for the data. Analysis. Really smart conclusions will answer these questions. How does your data confirm or refute your hypothesis? What does the answer tell you about energy transformation? I am looking for thoughtful responses on the following questions. How do your error sources impact your investigation? How do you know? What questions are left unanswered for you? What is the next step for this investigation? Helpful hints to consider. How does the energy transform from gravitational potential energy to other forms of energy during the motion? Make sure that you consider transformations into kinetic energy and other forms like sound, heat, elastic potential energy, and others you might think of. For full credit and maximum college and career readiness, document this project on your eFolio. I've just read the entire lab to you.